Hello everyone. Today I want to discuss the ArrayList class in Java. ArrayList is a generic type. When we write ArrayList integer, we specify the type we want to store right between the angle brackets. So here we have integer right between the angle brackets. And when we leave these brackets empty on the right-hand side, it's called the diamond operator, and it tells the compiler to just infer the type from the left side. So in this video, I want to discuss how ArrayList is actually implemented in Java. So let's take a look. So this first attempt to implement ArrayList is actually not fully correct, and I'll mention the issue later, but let's first take a look at the idea we have here. So first, ty is the type parameter. So for an array list, we will specify the type of elements that we want to store. It can be integer, it can be string, it can be boolean. So that's the type parameter ty. And we're basically just going to have two fields. One is an array of type ty, and the second field is int size, which keeps track of how many elements we currently have in the array list. So when we initiate a new instance of generic array, array is initialized to a new array of size 10, and size is initialized to 0. So at this point, we haven't added any elements to the array list, but we're basically initializing array to be of length 10. So as of now, we have 10 slots to add elements. So we have the get method, where we specify the index that we want to get, and we simply return array I in this case. And we have the add method. So if we add an element of type ty to this list, then we simply assign a to the index size in the array. We increment size by 1, and then if the size exceeds the length of the array, then we need to reallocate so that we have more room. So if we look at the reallocate method, we create a new array with twice the size, and then we copy over all of the elements from the old array into the new array. And then we assign that new array to be array again. So basically, if we run out of space, we have more than 10 elements, then we need to get a bigger array. And then every time the space is not enough, we call reallocate, so we have twice the length. So we have room to store more elements. But we see that there's an issue here. So if I hover over this, it says type parameter ty cannot be instantiated directly. So this is an issue, and the reason that we have this issue is because there is type erasure in Java. So let's take a look at this. These 4 lines, these 3 lines of code. Let's say if we initialize an array list called list that stores integers, and then we add a random integer into this list, and then we assign that element to the value of that to another variable. Then after we compile this, there's going to be type erasure. So what does that mean? Well, it's going to look like this. So in the main.class file, we're going to have the bytecode equivalent of this. And then, so instead of having the integer yeah, like this is the integer part is gone, so that's the type erasure. It is erased. And then when we call the add method, it just stores an object. But when we call get, right, in the original code we have list.get0, the compiler actually casts this to an integer. So that's actually how Java handles that. And so we can fix that. So let's comment out this. And let's take a look at what we have below. Yeah, so now there aren't any red lines anymore. We do get a warning here. And this warning is pretty annoying, but it's totally normal. And the compiler is basically saying that it can't verify this cast at compile time because ty is erased. But we as the programmer know it's correct. And if you want to silence this warning, you can just add suppress warnings unchecked. So that gets rid of this warning. But basically, what we had to do to fix the issue was instead of declaring, instead of having an array of type ty, we just have an object array here. So that means that when we, in the constructor, we also just have new object 10, so that's an object array. And then when we call the get method, we cast it to type ty. Yeah. So that's the fix. And we can test that this is a valid implementation of ArrayList. Obviously, we don't have all the methods that we would have for the actual Java ArrayList class, but we have the basic get and set methods and the add method. So let's take a look at this test class. So I wrote a class generic test, and it has one field, private and key. And then I have a nested class inside, which is called myArrayList. And this is the same code that we just saw. So it has an object array, and then it casts the value to type ty when get is called. And same reallocate method. And I also added another method, getSize, that returns the size. So we have 3 test methods. All 3 of them are static methods. One is testString, where we create an array list of strings using the code that we have, myArrayList. We add 3 elements. We test the get method, test the set method, and then we test reallocate by adding additional elements. And we check if the size is correct, and we print out the elements at the end. And we repeat the same test with an integer array, and the same test with an array list of booleans. So in the main method, we call testString, testInteger, and testBoolean. And then we do one last test with generic test itself. So this is this whole thing is in public class generic test, and we create an array list using myArrayList, specifying the type as generic test, and we basically add 3 different instances of generic test with different keys to this list. And then we check if the type is correct. We test the get method, test the set method, and test reallocate. Basically the same things that we did with string, integer, and Boolean. And we print out the keys at the end. So let's take a look at this program. So we need to compile this first, which generates a .class file, and then to run it, just run this. Okay, so yeah, this would be the correct output. It prints out the string array, array list, integer array list, and Boolean array list, and finally the key values for the generic test array list. So this implementation works fine. And one last thing I want to show is the code that actually implements the Java ArrayList class. So if you want to see that code, there's actually a very easy way to do that. You can just invoke an index out of bounds exception in Java, and then that will tell you where the problem traces back to, and that will be a line in the ArrayList class. So you can click on that, and then that will redirect you to the actual implementation of the ArrayList class in Java. So let's uncomment this. So basically, that's what I'm doing here. This array list contains only one element, but I'm trying to get the second element, which is obviously going to invoke an integer out of bounds exception. So let's compile this. And let's run this. Okay. Yeah, so we get an index out of bounds exception, and then here it is at ArrayList.get. Okay, yeah, so let's, if we click on that, then we get directed here. And this is the code that actually implements the ArrayList class in Java. So we see that here, right, objects.checkIndex, and the get method here, what it does, it says return element data index. So if we scroll up, yeah, it's right here. Yeah, so this is element data, and we see it basically returns it returns the object and casts it up to type E, which is exactly how we implemented our own ArrayList class. Right, and then we can check that element data. We can check that this is indeed an object array. See if we can find this. Yes, okay. So yeah, this part, yeah, this verifies that element data is, well, let's actually go further up, because we want to see where it's declared. Yeah, there we go. Transient object element data. So in the actual implementation of ArrayList in Java, they also use an object array, and they simply cast it to type E, which is the type parameter, when they return it. Yeah. So I hope you found this video helpful. I hope the volume is okay. And if you have any questions, feel free to ask them in the comment section. And let me know if you find this video helpful.